Hello. Today I'm excited to share with you an intriguing research paper titled The Use of Organosilanes to Inhibit Metal Corrosion, a review. I am Supanat and our group includes Pawapat and Athipat. In this paper, we examine the potential of organosilanes in the fight against metal corrosion. The objective of this review is to present methods for depositing organosilicon coatings onto metal surfaces with the use of organosilanes. These organosilicon coatings are applied before anti-corrosion polymer or paint coatings to improve the corrosion resistance and adhesion of the final protective layers. Organosilanes have the capability to create siloxane surface layers, and these siloxane layers play a pivotal role in boosting the anti-corrosive efficiency of polymer and paint coatings, making them highly effective in preventing corrosion and enhance their adhesion to the metal substrate. Siloxane possesses a unique mechanism of anti-corrosive action, making them invaluable in protecting metals from a variety of corrosive environments. The processes occur during the hydrolysis of organosilanes in aqueous solutions and their interaction with metal surfaces.
So now I'll be talking about the uses of organosilicon nanolayers on metal surfaces. On our research paper, we found that they work very well on metal surfaces to help with corrosion. Here are some of the reasons why they work on metal surfaces. First of all, corrosion resistant. Organosilicon nanolayers provide an effective barrier against moisture, oxygen, corrosive ions, which are primary factors to lead to metal corrosion. The nanolayers act as a protective shield, preventing these harmful substances from reaching the metal surfaces. Secondly, adhesion and durability. Organosilanes can chemically bond to the metal surfaces, ensuring strong adhesion and long-lasting protection. This also prevents corrosion from happening in every environment, especially with moistures. Thirdly, customization. Organosilicon nanolayers can be tailored to meet specific corrosion resistant requirements. By adjusting the composition and structure of the coating, one can achieve the desired level of protection, whether it's for mid to severe corrosion-prone conditions. Thirdly, minimal impact on dimension. Organosilicon nanolayers are extremely thin, typically nanoscale. What this means is that it provides protection without changing the dimensions and appearance on the metal substrate. Okay, fourth, versatility. Organosilane coatings can be applied to a wide range of metal. This includes steel, aluminum, copper, and other more. It also is very suitable for various industries, such as aerospace, marine, and electronics. Thirdly, it improves aesthetics. What I mean by this is that other than corrosion protection, organosilicon coatings enhances the appearance of metal surfaces, makes the surfaces more smooth and glossy. Next, it reduces maintenance. What I mean by this is the use of organosilicon nanolayers extend the surface life of the metal component and reduces the need for frequent maintenance and replacement, which can result in cost savings. Okay, next, compatibility with other coatings. Organosilane coatings can be used in combination with other protective coatings, such as paint system, to provide synergetic corrosion protection. Next, minimal environment impact. The organosilane formulations have very low level of volatile organic compounds and are considered more environmental friendly compared to traditional corrosion protection methods.
The many protective properties of material coatings are determined by the strength of adhesive bonds at the metal-polymer interface And since organosilane molecules are bifunctional, this makes them a very great material treatment choice. By bifunctional, it means that the molecules can simultaneously interact with both the surface of the material and the coating. So for example, by treating a material with organosilane aqueous solution and apply a polymer coating, the positive properties of the coating will be significantly improved. Now, these are the key reactions and mechanisms of how organosilanes improve the most important property, which is corrosion protection. When a polymer coating is applied on an organosilane modified surface, the interpenetrating diffusion occurs, which means the anodic dissolution will be decreased, causing the corrosion rate to also decrease. One more thing to note is that negative charge tends to prevent the absorption of corrosive chloride. Thus, ionic sulfur groups are introduced with imidodiacetate groups into the organic radical of silane molecule to produce the siloxane layer, and this layer reduces the absorption of water. So to summarize, the implementation of organosilanes on metal surfaces alter the surface charge, increase the corrosive chloride ions control, and add a protective siloxane layer, making the metal less prone to corrosion.
These are the references. In conclusion, using the organosilane nanolayers on metal surfaces can prevent corrosion and increase metal's durability, effectiveness, and versatility. The reactions involve altering the surface charge, controlling the adhesion of chloride ions, and forming protective siloxane layers. By using organosilanes, we are not only combating corrosion more effectively, but also taking a significant step toward environmental sustainability. Thank you.